Looks like we're live. Hello everyone and welcome to yet another recreational programming session with Mr. Zozin. So let's make a little bit of announcement and officially start the stream. So red circle, live on Twitch. And what are we doing today on Twitch at .television website? Today we're checking out a thing called UXN. Right, I don't know, I don't really know what it is, but this is something that's been on my to-do list for quite some time because people talked about it, so that's what we're going to be checking out today. I'm going to give the link to where we're doing all of that, twitch.tv/Toading, and I'm going to ping everyone who's interested in being pinged, and there we go, the stream has officially started. So, today we're checking out the UXN Varvara ecosystem for like a personal computer thing. So yeah, it's a personal computing stack based on a small virtual machine that lies at the heart of our software and that allows us to run the same application on a variety of systems. So somebody suggested this to check this thing out quite some time ago, and then after that several people as well mentioned this thing. So it must be something interesting. I'm gonna leave the link here in the chat. And of course, for people on YouTube, I'm going to put it in the description. So I think I forgot to prepare the description. So let me quickly do that. UXN and UXN. So it's a small virtual machine, right? So it's quite interesting. It's designed with implementation first mindset. So the link goes into some sort of like a article or whatnot. It is tailored to a specific need for hosting graphical applications, but is entirely open and welcome anyone to adapt as a release target. UXN is programmable in its own unique language, right? UXN TAL. So what's that? TAL is a programming language for UXN virtual machine. UXN programs are written in a stack-based... I see what's... Okay. People... I guess this thing was suggested around the time I was making Porth, right? So people saw me doing like a stack-based virtual machine. Oh, you might be interested in this and other thing. Okay, I see what's going on. And it's literally Porth. Okay, I see. It's okay. That's very interesting. All right. And the distribution of UXN programs is akin to sharing game ROMs for classical console emulators. Oh, and that is already fucking interesting. So it kind of reminds me of Pico 8, I think. So there was a thing like a Pico 8, which is also like that, but it's like a fantasy console. Yeah, it's a fantasy console. And on top of that, it's actually paid software. You have to buy this shit to use. This thing, I suppose, is free and open source, right? So I think I even did Pico 8 stream. I think I even still have a license since the times I was able to pay for this kind of shit. So maybe we're gonna do another Pico 8 stream at some point. So I think I need to make a reminder to do another Pico 8 stream because the previous one was actually kind of cool. Right, so let me actually put that in here. So yeah, sort of like a Pico 8, but in Pico 8 you program in Lua, so essentially you're using Lua virtual machine technically, right? And the ROMs are distributed through PNG files. Pico 8 is kind of weird in that sense, right? I do not fully understand it, but it is what it is. So console emulator learn blah blah blah. So desktop version. So you have to run UXN programs, you will need an emulator that works on your system. Below are links to emulators for major operating systems and for more obscure environments. Okay, so we have a Linux emulator. So let me actually download it. All right. Let's go, my friend. We're onto an adventure. We're going onto an adventure. So I'm gonna just like wget this scheiße. I hope it's not that very big. So it's 101 kilobytes. So let's do the unboxing. Right. So what's the unboxing experience? That was fast, right? So that's actually pretty fast. So we have a bunch of ROMs and seams, and those are binary files. And I suppose these are executable files. You have UXN ASM, UXN CLI, UXN emulator. So I suppose this is an emulator, right? So UXN, I want to type Unix, right? So this is the first reflex I have. UXN emo, it's actually executable, right? So if you take a look, it's an ELF. Right, so in terms of dependencies, what does it depend on? Holy shit, okay. So it's a full-fledged SDL2 application. All right. Okay, so let's actually see. So it's supposed to provide a ROM. What kind of ROM can we provide in here? So is there some... Okay, so there's a calculator. I suppose... let's just run a calculator. And it is a calculator. We've got a calculator. So there's a tiny little cursor in here. How can I make it bigger? How can I make it bigger? Okay. What's that? So there is some sort of a sound. Right, so there is some sort of a sound. Why is it constantly going? Alright. That's kind of weird. I have no idea what that is. But that is so bizarre. That is so bizarre. So, what other things we have in here? So we probably have Orca. Right, so what the fuck is Orca? What am I looking at? What? So there's menus and shit. What the fuck is this? What the fuck? How do I write shit for this? Like, is this some sort of a game? This might be a game. So cat clock. So there's a cat clock. Yo, look at that. Look at that. Can your stinky JavaScript with React do that? I don't fucking think so. Eat that, React people. Eat that. So yeah, that's pretty cool. How can we... Okay, so that's cool. You have virtual machine. You have ROMs. How can I write shit for this thing? So this is the really interesting question. So, oh, it comes from the... This is a Windows XP, isn't it? So it's an old project. So it's a straight up old project from like Windows XP times. What the fuck? What an actual fuck. Alright, so UXN guide. The same UXN ROM can be used on a variety of desktop computers on tiny... This is actually a pretty cool idea, honestly. This is actually a pretty cool idea. Right, so you have like a small virtual machine and you can distribute... I mean, it's basically like JVM at that point, but it's a sort of like a recreational machine. And do I understand correctly that they... Oh my god, so they have like a hardware implementations of this thing, don't they? UXN can also run on classic consoles and on all electronics. Okay, currently there are ports, not all are complete. So the emulator is small enough to run on like old consoles and shit. That is very interesting, actually. That is very interesting. But is it possible to like make an actual hardware of that virtual machine? So, right. The thing about Pico 8 is that it's a fantasy console, but you can't really implement like a hardware version of this thing, right? Because it's a pretty complex thing by itself. Right. Maybe UXN is such a small, simple machine that you can literally implement it on hardware without emulator. But I don't really know, so maybe I just need to read some documentations and stuff. So, doubtlessly the microcontrollers they list don't include FPGA chips. Oh, okay, so that's very interesting. So you guys already looking into this thing, right? You're already looking into this thing. I'm interested in like a programming part of this stuff. UXN guide. So UXN guide, our general purpose. So this is how you build this thing. Maybe we should look into the programming language, right? So there's some sort of a book, right? Some sort of a book. UXN stack-based flavor of assembly designed specifically for this virtual machine. TAL files are human-readable source files. ROM files are UXN-compatible binary program files. Applications that transform TAL files into ROM files are called assemblers. Sounds logical to me. So to get started, equip yourself with an emulator and assembler for your system. Okay, we already have an assembler, don't we? So there's a UXN ASM. Right, so there's UXN ASM. And there we go. So, okay, this is pretty straightforward. So maybe we can create input tal. Is there like a tal module, mod for Emacs, Melpa? So Emacs tal mod. Emacs tal mod. There is a tal mod apparently, okay. So tal mod provides Emacs tal translation portable. Is that the thing? Transactional application language. I don't think that's what it is. Maybe we don't really need that, right? So maybe we don't really need that because it's like a very simple, it's just like a sequences of words, I suppose. Okay, Unix tal syntax in a concatenative programming. Okay, so they even list link to concatenative.org, right? By the way, did you guys know that somebody added ports to concatenative.org, the website of concatenative languages, right? So somebody actually added port, and port is a dead language. So, oh, they even oh my god, a stack-based concatenative strongly typed compiled programming language that is self-hosted port is developed by... It makes it sound like I'm some sort of like a famous software developer. It's that famous creator of that yes. He, like, you give me too much freaking credit, I mean. Okay. Anyways. I'm just a shit poster on the internet, okay? I'm just a shit poster on the internet, so you're being too official. Alright, so in concatenative language, there are no precedence rules. The calculations are merely performed in the sequence in which they are preserved. The order with which elements come off a stack is known as the last in, first out. Okay, so we are aware of that. I've been programming for almost 20 years. Thank you so much. Okay, so I suppose we're pushing some numbers, we're duplicating them, we're adding them together, and we're multiplying by 3. So essentially, the result of this thing is going to be 6, and they even indicate that in here. So the result actually is 6. I don't really know why they prefix numbers with this sort of thing, right? So I don't really know. So is that like a based stuff? The question is, how do you print text? Okay, so there is a print text example program. The first line of the programming example begins the absolute padding token. The absolute padding token. So it's like an absolute unit of a token. It's an absolute padding token. Alright, so I have no idea what that is. So there's something called absolute padding token, which is a bar 10, which moves the program right in locations. Oh, okay, so it's like it has like a head. It has like a head. You can move that head to different addresses, and it will allow us to define labels and sub-labels for the various ports of the console device, so that we can reference them in our code by name. Yo, so console device. Alright. So we're moving the cursor at that specific address. We're creating a bunch of tokens. So this is the label. So I suppose thing that starts with @ is a label. Things that starts with ampersand is a sub-label. So I suppose this thing, console, is in fact a label. Then we have a bunch of sub-labels that are ampersands. And what are the dollars? I have no idea. But okay. So then I suppose this thing moves to this specific address, and we're just doing hello world printf. I have no idea what the fuck is that. So then print text. So we call in print text, and print text is defined somewhere here. So this reminds me of fourth, actually. This reminds me of fourth, because in fourth, there is this convention for defining words. If you Google up fourth, define new word. It is very much inspired by fourth. I can see that. I can definitely see that. Fourth. Thank you, DuckDuckGo. I really appreciate for defining the word fourth. I really fucking appreciate that. Thank you so much. Fourth programming language. So yeah, there we go. So this is how we do that. And essentially, right, so you do that with a colon, you say the name of this thing, and then you have this convention where on the left side of dash dash you have the inputs for the function, for the word. On the right side of dash dash you have the outputs. And I kind of inherited that convention in Porth as well, if you guys remember. I kind of inherited that convention from Porth. And for instance, here, constant, as you can see, it accepts n, but it doesn't return anything. It just consumes the n. And I presume this is a similar convention. You have something called print text, which starts with at, which probably means it's a label. It accepts a string and doesn't return anything. And then it creates a, okay, so it defines a label while, then does something, probably prints something on the console, right? Then jumps back to the while, right? So it basically references while back. By the way, I don't know what any of this shit means, like, at all. But that doesn't matter. That's kind of the point, right? So I'm using my brain as a sort of pattern recognition. Right, so I'm just trying to see the patterns and find connections between them. Right, so they said that the at are labels, so I define a new word at here, and I call it print text. So here is the loop. So this is sort of like a sublabel, and here I'm sort of like jumping to that sublabel, if that makes any freaking sense. So and then at some point I just do hello world. Right, so this is a lot of text for a simple hello world, honestly. For my liking. If it's a simple like virtual machine, I think a hello world should have been a smaller and simpler thing, right? It's kind of like throws too many new concepts at you right away, and it's not particularly great when you're like learning things, right? I suppose it's sort of like a learning environment, but maybe it's not for learning. Maybe it's actually legit like a target platform for something. Right, so, but if it was for learning, I think it should have been like the first experience, the hello world should have been simpler, in my opinion. So they throw at you right away a notion of console device, right? So what the fuck is a console device? Something located. The console vector is evaluated when a byte is received. So port holds one of 5 known types: no queue, std in, argument spacer. Okay, so yeah, they throw a lot of stuff at you, right? That's a cute drawing, actually. What the fuck? I didn't expect that. What the fuck is going on? It's just like I'm looking at like a very dry technical documentation, and all of a sudden just like a drawing of cute character or something like that. What the fuck? All right, so maybe I should not overthinking it. So let's just go ahead and copy paste this thing and put it in here. And I suppose we can just do UXN Asm, and I can just like try to compile it. And it's supposed to provide the output ROM, right? Assembled output ROM in 31 bytes, right? 9 labels, 0 macros. It has macros. So we have 9 labels, and the question is, what are the labels? Are these labels 1, 2, 3, 4, 5, 6? Right, so I didn't really like this thing. So it has right, does it have while? Right, while is only defined in here. So there is 6, 7, 8. So what counts as the label, actually? What counts as the label? So 1, 2, 3. So there's 3 of them, but then we have also these things. 3, 4, 5, 6, 7, 8. 9. Oh, okay, so label is also a sublabel, right? So there's exactly 9 of them, right? So including sublabels too. So that checks out. That actually checks out, okay. So, and that created the output ROM. It also created some sort of symbols, right? Which, okay, so it's for labels and different console devices and stuff like that, right? So, and the ROM itself is actually very simple. It also stores its own data, right? As you can see, so here is the hello world. It also baked that hello world into this thing. So where's hello world that we have in here? Okay, so here it is. So it is like assembly. Actually, it is like assembly. We define it a label, and here we literally just put the data, but it's the weirdest way to define data, honestly. Like, what the fuck is going on? So 20. So I suppose, how many characters? You have 5 characters in here. You have 6 characters in here. So I'm suspecting that you're literally using slots of the stack as like a storage, and then that is so bizarre. And you say that, okay, so these characters are going to be part of a single slot, a single number. So that is very much bizarre. This is very much bizarre. This is such an interesting and fascinating language. Like, I have no idea what am I looking at. But we created a ROM. So if I do UXN emu and then just do output ROM, it just did hello world, but on a standard output and did nothing on a screen. I suppose to do something on a screen, you have to write into specific device. You have to write to a specific device. That is such a bizarre and fascinating thing. Like, what the fuck? It's just like, it's like, I don't understand what the fuck it all is, but it's really fucking fascinating. Alright, so let's continue reading. So the second segment moves the program location to the... Okay, they actually explain what the fuck is going on here. Holy shit. So let me see one more time. So this 10 thing move the program writing location to the address this and allows us to define labels and sublabels for various ports on the console device so that we can reference them in output code. Okay, so this is where a console device starts, right? And we are defining console. So this is where we have a console and then sublabels, vector. Write is one of the sublabels, right? So you see, we defined label console, then we defined sublabel write, so it's a sublabel for console. And then when we reference into this thing, we are referencing to it as .console/write. So that's sort of, this is basically the relation between them. So console and sublabel write. I still don't quite understand what are the dollars, right? So what do they have to do with anything? Are they just the data or something? Like, I still don't know, but I think we're getting closer to understanding what the fuck is going on generally. I think that's what is going on. All right, so the second segment moves the program location to the address 100, which is where the first page of memory ends. So there are pages of memory, and they're sort of like this size. If you take a look at the hexadecimal, so 120/24, is that what it? No, 256, right? I don't really know hex, I'm really sorry. I don't really know hex. So, which is where the first page, so the pages are 256 bytes, essentially. Maybe not even bytes, but maybe some sort of like words, I don't know. So is there a description of the virtual machine itself? So maybe there is somewhere, but I jumped into the language guide. Maybe I should have actually jumped into the virtual machine. So there's a small virtual machine. Oh, okay. Okay. Wait. Is that the entirety of the virtual machine? The fuck? Oh, I mean, okay. That is I suppose the main difficulty for the emulator is to wire up different devices and everything, right? So because this thing probably doesn't wire up different devices, right? It's just like a simple virtual machine, right? Anyway, so console device. So to learn more, see UXNTAL structs, right? So these are the structures. Using the and defining data structures in UXNTAL. Enumerations are labels with unique values that can be used as constants in a program. They begin by rolling back to the program address with 0. Okay, so that's pretty cool. So I suppose these parentheses are comments, right? So these parentheses are comments, similarly to fourth, right? So we move in here. So we define the structure suit, and these are the fields: clubs, diamonds, hearts, and spades. And then the usage. So there's this thing. Structs define padded labels. For example, this person age label holds a value of 2 using the offset allows to access. Okay. Right, so you define a structure person with a name that has value 2, the age value 1, and height 2. Right, so and then you have members, and this is like a dictionary and stuff like that. So there's some constants, prototype label can. Okay, so that doesn't tell me anything. Okay, well, let's move on. So let me see. The second segment moves the program location to the address this, which is where the first page of memory ends and where all UXM programs begins. Okay, so we'll so there is a memory. There are 64 kilobytes addressable memory. ROMs are loaded at OK, which is the address of the reset vector. Once a memory UXM program can write over itself, it is not uncommon for UXM program to store values in its own runtime. Memory is big endian. Really? When writing or reading a short from memory, the position is that of the high byte, the low byte of short byte, blah blah blah. All right, so let me see. So next is a comment. The arrow symbol indicates that the following operator is a vector and will terminate with the break. To learn more, look UXN notation. Okay, so that's actually very cool. Using stack effect definitions. Maybe this is what I should have started with, right? So, okay. So this is a spacer. So they say that this thing is a vector, right? And it terminates with the break, and then it just does hello world. And what is hello world? Hello world is it's that label, and then you call to the print text, and print text is separate. So they specifically split the implementation of hello world into two parts to probably demonstrate how this entire shit works, but I don't really know if that's super necessary. So I suppose jump to R is jump to return. So the question I have, so first thing, to sort of like demonstrate an understanding of what the fuck is going on, can I inline print text? If I just do the following thing, like this, will this entire shit work? Will this entire shit work? So it feels a little bit unnecessary to have like a separate function to just print hello world. Right, if I understand this entire thing correctly, that should just work. So this is where the program starts. This is some sort of a comment, right? It's sort of a convention. We're pushing the pointer to hello world data in here, right? And then we're sort of iterating, doing some mumbo jumbo. I still do not fully understand that. The result of this mumbo jumbo is probably two things on the stack. So we're just popping them from the stack, and then we're breaking, effectively terminating the execution of the program. I suppose that's basically what is going on. We can try to build this entire thing. It does in fact build. We reduced the amount of labels to 8. Remember, we had 9 of them. Now we have 8. And I wonder if it's still going to work. If it's still going to twerk. It's still working. It's still twerking. They overcomplicated hello world. Why the fuck do they show you a bloat? Why the fuck hello world is so goddamn freaking bloated when you're learning things? I'm fucking disappointed. This is supposed to be a hello world that just demonstrates like a very simple thing. Like, why are you throwing people into separate functions and shit? Bruv, come on. I'm pretty sure you can simplify this shit even further. You can... Who wrote this shit? Java developers? Are you Java developers? By the way, I'm joking. But to be fair, there is a fair bit of criticism in what I'm saying, right? Even though I'm being ironic, but there is a fair bit of criticism. Right, so this is supposed to be hello world. So why are you needlessly overcomplicating it? Why are you needlessly overcomplicating it? Like, why separate function? I know that you want to show off different features, but the first experience must be, here's the simplest possible thing that just works. Let's start from here. Do not overcomplicate. Do not overcomplicate. Please, I fucking beg you. At least the first experience. The first experience must not be that complicated. Anyways. Okay, so the command, the arrow indicates that operation is a vector, whatever the fuck that means. So whatever the fuck that means, vectors. UXN is non-interruptible. Vectors are locations in a program that are evaluated when certain event occurs. A vector is evaluated until break opcode is encountered. UXN can communicate with a maximum of 16 devices. Each device has 16 ports. Each port handles a specific I/O message. Ports are mapped to the device's memory page, which is located outside of the main addressable memory. Okay, so I suppose it's like an interrupt vectors in x86. Right, so, and entry point is one of the vectors. Right. An entry point is one of the vectors, and event that it handles is started the program? I guess. Makes sense? Makes sense to me, I guess. Oh boy. So if parentheses are comments, that means I can straight up ignore this shit, which is good. Which is good. Okay. So the hello world token pushes the absolute of an address, right? Absolute address made of 2 bytes onto the stack. So they're operating on 2 bytes usually. This is what I noticed, right? So they are basically operating on 2 bytes. So, which is kind of interesting. So they're operating on 2 bytes. And maybe the entire memory is also addressable in 2 bytes. So how much you can address in 2 bytes, I don't quite remember. So yeah, that's basically like 6502, isn't it? I think that's basically 6502, but I never actually programmed 6502. Yo, that sounds like a cool idea for a stream. 6502 assembly stream. So it pushes an absolute address made of 2 bytes onto the stack, and which points to a series of characters in memory. A hexadecimal number or a label pushed to the stack in this fashion is called literal, as opposite to a value stored in memory. Okay. So yeah, so you have just a pointer and you have the data separately. Right. So essentially here you pushing an address to this data, but the data stays in memory. But you have an address on the stack, on the operand stack. Right, so that makes sense to me. So then they call that literal. Next we call the print text routine. Okay. Both &while and @while are ways to define labels, but using the ampersand rune will prefix our new label with the name of the last parent label, creating print text while. So the basically relationship between labels here is similar to sublabels in many x86-64 assemblies that I programmed in, right? So quite often, right, in x86-64 assembly, you can define a label, which is, for example, main, right? And you can do different things in here. So move rax69, move rbx 420. And then you probably want to do something in a loop. And you can define dot loop in here. You can do some things in here and then you can jump into dot loop. So the cool thing about these sublabels is that they're always prefixed with the main label that starts before them, which creates sort of a namespace. So then in the next function, foo, you can reuse the same label again and they're not going to collide. You know why? because they're prefixed with the corresponding main label in here, so technically they're different labels. So I suppose this is the same sort of energy, this is the same sort of vibe, this is the same sort of idea. You have main labels and you have sub-labels which are automatically prefixed with the name of the main label. And this is how we got the console/write. Right, so here we have some sort of a structure. Here are sub-labels, they have these sort of values in there. They have some sort of, this is, wait a freaking second. So if I'm doing a write, so here's the interesting thing. I do not use read, I do not use pad, I do not use error. And when I'm referring to this thing, I'm basically pushing a value of 1. Is that what I'm, chat, do I understand correctly that I can nuke this entire shit and just replace this thing with 1 and it's still going to work? Do I, who, please don't tell me that this is the case. I'm gonna be fucking mad. All right, so the chat tells me that I can't do that, but we can check that, by the way. We can check that. So first of all, let me see if I can comment this thing out. Let me try to comment this thing out and just try to do the following thing. Okay, so unknown 0-page reference console write, and it doesn't even tell you where it happened. Maybe 8. So people say, so it doesn't tell you where the error happened. So it happened here, right? So I'm referring to this thing, but they don't say the line or anything or whatever. I'm disappointed. I'm genuinely disappointed, right? It doesn't have to be a super complicated reporting system. Just tell me at least the line. It's not that hard. So you probably know that information. You probably do know that information. Anyways, so, and I can probably comment out this thing, and I suppose this is supposed to be right, so I'm gonna put it like this, right? So it assembled, and now we simplify this entire thing to 2 labels, right? We simplified it to 2 labels. Let me see if I can now run this entire, nah, it's not going to. Okay, chat was right. Chat was right. Apparently I can't just do that, so it has to be, I just don't understand what exactly this entire thing means. But I wonder if I can maybe, can I just get rid of everything except write? So there is also padding, right? So probably won't be able to do this kind of thing. So let me try. Oh, okay, so if you want to have a comment, it has to be like a separate token. Yeah, so, and if I try now to write, nah. All right. So that means we're not there yet. We're not there yet. So let me try to do that, and yeah. Wait a second. Why did it stop working at all? It stopped working completely. I think I did a fucky wacky chat. I think I did a little bit of a fucky wacky. Oh yeah, remove 1. Yeah, that's right. So that means I need to repeat that experiment yet again. Yeah, I need to repeat that experiment yet again, where I want to try to do that. So a little bit of a highlighting would have be appreciated, but I don't know. I don't want to spend too much time. Yeah, okay. But if I try to do that, and then output. Okay, so this is very important, by the way. This is very important. It is very important to mess with the code and see what works, what breaks, and what not, because this is how you gain understanding, right? So I'm not failing at doing something. Well, I mean, technically I do, but I'm exploring, right? I'm testing a hypothesis. Okay, the hypothesis was wrong. So I'm gonna continue just reading and see if I gain more understanding. All right, so we figured out that the at while and ampersand while are just, you know, labels and sublabels and stuff like that. Next, the LDAC opcode copies the absolute of an address on a stack and loads the byte in the memory found at that address. Copies the absolute address on the stack and loads a single byte in memory found at that address to top of the stack. So what do you mean copies? So it basically consumes. Okay, load AK. So LDAK, load AK. All right, that's cool. So we start here. We put address of hello world onto the stack. So this is just a label, we can ignore that. We load whatever the byte at that specific address. We writing that byte and then we deo that big. We deo that big. So, and that value is sent to device port with deo. So I suppose, so here you have a byte that you read from there. You have a byte that you read from there. Then you push the value. Right, so the device port 18. I remember chat was saying something about 18. I remember the chat was saying something about 18. So that means I can replace this thing with 18. Chat, do I understand correctly that that shit is going to work? Right, is that what you're saying, chat? I remember you were saying something. Freaking, why did you remove all of that shit? Freaking remove all of that shit. Creators, people who documented it, remove all of that crap. Remove all of that crap. Two things, two remarks. Report the lines where the errors happen. Very fucking important. Simplify hello world. It's the first goddamn experience. Do not overcomplicate it. Do not freaking overcomplicate it. Anyway, so I should probably not remove the comments because maybe they're going to be useful, right? So maybe we're going to be using them. But anyway. What you expect from Windows XP users? I mean, I expect things to be simpler. Because Windows XP was a simple operating system. Actually, Windows XP is one of my favorite operating systems of all time. I like it better than Linux. Man, I wish we could back to Windows XP times. It was a perfect operating system. Why the fuck did they discontinue it? You know what? You know what? So as far as I know, there is a lot of like a government entities still use Windows XP. And there's quite a few people who would like to still use Windows XP. Microsoft open sourced that shit. Seriously, fucking open source Windows XP, we're gonna continue like supporting it and updating it and everything. It's just like, just give it to the community. I mean, it's an old operating system, like, but come on. Why not just do that? I know why they're not gonna do that. Because everyone's gonna ditch their fucking shit operating system, Windows 11, Windows 10, and other operating systems. That's why. Everyone is just like, oh, I'm going back to Windows XP, fuck that shit. Anyways. So I wonder how did we come to the, if it's a port 18, so, man, I still don't understand these like dollars. That's why hello world must be simpler. You're throwing too much shit at the user. You're throwing too much, but maybe that's your goal. Maybe that's your goal. Maybe you are a gatekeeper like that. Right. So you're trying to weed out like a script kiddies and stuff like that. So, okay, I see what you're doing. I see what you're doing, creators. I see what you're doing. The gatekeeping and shit. That value is set to the device port 18 with a deo. All right. Which is a good thing. A healthy dose of gatekeeping is not a bad thing, honestly. Okay, so here, okay, I see. The console device, it starts at 10. Right, so you have read, so you have a vector. Is that the width? That might be a width, actually. Right, so you have a vector and they say the width is 2. This shit just clicked in my head. I fucking understand it. This is the width of that field, isn't it? It's the width of that field, right? So vector is 2. Okay, so this is the two things. Then read is 1. Pad 5, which means we skip 5 of them. 1, 2, 3, 4, 5. Next is write. I know Kung Fu. What the fuck? I just understood it. Okay. That's cool. So it's the width. It's the size of the field, right? So, all right. And, okay. So the actual value is indicated with the hashes, right? The actual value is indicated with the hashes. But this one indicates sort of size of the field, maybe something like that, but I kind of vaguely understand what the fuck is going on. So yeah, essentially we move the sort of address in here and we say that at that specific address we have that structure with this layout, but we don't really have to use that structure. We can just directly say address here, but for the convenience of the user we can... Okay, I see what's going on. Not bad, actually. I kind of like that. All right. So I suppose, like, after that, the data is completely consumed, right? So if this thing consumes the pointer and reads the byte, so that means on the stack, okay, so let's actually take a look at the state of the stack. You have hello world, load world, LDAK consumes this entire thing and replace it with a single like H byte. Then we push 18 in here. Then we DAO that big, basically sending that byte there, so we have nothing. So that means LDAK does not consume the address. It does not consume the address, as the documentation says. It copies. Yeah, it copies absolute address on the stack. Okay, so that's the thing it does. It does the following thing, that then reads the byte out of that address, then we push 18, and then with DAO we're sending it to the output device, and we're ended up with this thing. Okay, makes perfect sense. So then we increment 2. I have no idea what the fuck is that. Why we do increment 2? I would expect this thing to increment 1, but then we increment 2. And why we load AK again? So that doesn't make any sense, so let's actually read this thing. We increment the absolute address found at the top of the stack with increment 2 because the address is made of 2 bytes. We load... What? That's a very interesting justification of using inc2, but we increment the absolute address found at the top of the stack with inc2 because the address is made of 2 bytes. All right. We load the incremented value next. Next we do a conditional immediate jump with this. For as long as the item on the stack is non-zero, we use pop2 to remove the address on the stack and keep the stack clean at the end of the subroutine. That doesn't make any fucking sense. What the fuck? Just a second. So inc operates on a byte, inc2 operates on a shot. Okay, so that makes sense. So essentially, if I just do inc, I won't be able to address more than 256. Right, so if like lower bytes overflows, so the upper bytes is not going to be updated. Is that the case? I suppose. Right, so that's very funny. Okay. So we increment the address. We increment the address. Why the fuck are we loading anything in here? I see. So this is a conditional jump. This is a conditional jump because at the end of the string we have 0. Freaking null terminated strings, mother flipper. Null terminated strings. Right, so essentially we increment, we load whatever we have in there, and with a question mark, right, so we only jump in when it's not 0. Makes sense to me. And afterwards we do pop2 because it's 2 bytes. So we use pop2 to remove address on the stack and keep the stack clean at the end of the subroutine. So I really like how you, like, it's so fucking funny. You're reading like a dry documentation, and all of a sudden, just like a cute drawing of a cute character just pops up. This is so cool. What is this project? Who made this? Who freaking made this? Is amazing. What the fuck? And you know this is a goat. You know this is a goat because the pupils are horizontal, right? So this is a goat. An artist made. Okay, so I can understand that. I also a little bit into drawing illustrations, right? I wouldn't call myself an artist, right? But I do like to draw illustrations. And for instance, even on Twitch, there are panels at the bottom. I draw them all myself, right? If you're interested to know what kind of art I can create, so I made them myself. So I can appreciate this kind of thing. This is super cool. This is super cool. I really like that. So far, project gets 9 out of 10. 9 out of 10, right? It's really nerdy. I really love it. I really love it. There's a heavy Plan 9 influence as well. Yeah, I can feel that. It really gives off this Plan 9 vibes, which is super cool. And I haven't checked Plan 9 unfortunately. So one of the things that are on my to-do list, maybe I'm gonna check it at some point. But yeah. So pop2, I suppose pop2 is because it's a 2 bytes. So that means, oh, that means just a single pop pops 1 byte and another byte stays on this. So the elements on the argument stack, they kind of have a regular size. Is that what's going on? So essentially, like, you can have 1 byte elements, but you have operations that treat 2 bytes on the stack as a single thing and operate as a single. This is, okay, that's very interesting. I should take a note of that for the designs of my virtual machines, because I never thought that you can do that. That's a very good idea, actually. That's a very good idea. Okay. Okay, I can claim that I fully understand this example. I fully understand this. No. I still don't understand what the fuck is this shit, honestly. So I suppose we just push. Okay, so this is probably something with the tokenization, right? So the tokenizer is probably very simple. It's for the same reason why you can't do shit like that, right? For the same reason you can't do shit like that. So maybe something about the tokenizer. But let's actually read what is going on here. Lastly, we encounter jump to R, which jumps to the absolute address that we left on the return stack. Okay, so we removed that thing from this example, right? So we removed that thing. So left in the stack, then we enter the print text subroutine. Okay. To summarize, the uppercase codes are reserved words, uppercase words. All right. Just a second. Lowercase hexadecimal numbers are bytes and shirts. Parentheses are, well, curlies are lambdas. Summarize, you never actually mention that anywhere. And square bars are used for organizations. Runes are special characters at the start of the word that define its meaning. Here is the full list. Okay, so this is absolute, relative, parent, child, literal hex, row, okay, row, okay, I do understand what's going on. addressing runes. Literal relative, row relative. Okay. Immediate rune. So jump. So this is just jump, and this is conditional. Okay. I see what's going on. And you have different stacks. All programming in UXO is done by manipulating and the working stack and return stack. Classical fourth situation. Right, I think fourth also has two stacks, the working stack and the return stack. And generally, to be like useful and Turing complete, you kind of need to have two stacks, right? So yeah, that makes sense. So we have pop. So discard top item element contains. So here are opcodes. That is very poggers, meine Freunde. That is very poggers. But you know what? I want to do something cool. So printing text to standard output is very cool. It's very 70s. I do understand that. But we need to do something more interesting. I want to do graphical shit. I want to try to do graphical shit. I'm already streaming for 1 hour, right? And I think we've got a pretty good progress. In 1 hour, we managed to decrypt this thing, right? Which at first I thought is going to be impossible to do in 1 hour, right? It was a little bit daunting, right? So I think, like, I still hold an opinion that the creator should have not thrown so many things at you at first. And especially they should have not explained that, you know, parentheses are comments somewhere at the end of the chapter. I think they should have taken this thing and put it at the top. Like, just, here are the things that you have. Right, here's the map, and here's the forest. So you don't really put the map of the forest at the end of the forest. No, it's not how it works. Anyways, so I want to make a small break, and after small break, I want to look into the graphical capabilities of this entire thing. Right, so I presume that to draw stuff on a screen is going to be similar to working with a console. It's probably some sort of like a device, and you will just have to, you know, write into the ports and it will display on the memory. This is my hypothesis. We'll see how it goes. All right, let's make a small break, and all right. So let's continue. So we need to find how to do graphics, right? So we figured out how to do these kind of things. So we have stacks, we have opcodes, right? So, all right, that's, I really like the drawing, oh my god. Immediate opcodes, so there's a memory, 64 kilobytes of addressable memory, that's understandable. The devices are very interesting thing. Maybe we'll need to actually read about the devices, because doing graphic is probably one of the devices, the display probably. UXAN is non-interruptible. Vectors are locations in program that are evaluated when a certain event occurs. A vector is evaluated until a break opcode is encountered. UXAN can communicate with a maximum of 16... Oh, yeah, so we already read that. 16 ports, blah blah blah, ports are mapped to devices. Begin by executing the reset vector. Okay, so it's called the reset vector. So basically entry point data between vectors. The content of the stack are preserved between vectors, but it is discouraged to use these stacks to pass data between vectors. Okay, that's very interesting. Ooh, okay, so set a vector. Mouse vector, so you have data, so this is the vector. So in a reset vector, it is your responsibility to set certain vectors on certain events. Oh, okay. So then you have a mouse. Okay, that is so interesting. But then how you do that? For example, address stored in a vector ports. Points to part of the program to be evaluated when the cursor is moved or button state has changed. So, okay, so this is that. What is... Right, so Varvara. What is Varvara though? Is a computer system running on UXN specification devices. All right. So yeah, we already have that. I want to close some of these things in here that are not really important. So I suppose Varvara is the system, right? The system itself, sort of the virtual machine. UXN, it's kind of difficult, like a specification for devices. Communication with UXN CPU is a computer system running on UXN. The terminology is kind of weird, honestly. Terminology is kind of weird. So let me take a look at the mouse. So here is the mouse. It is located in here, right? So, so mouse device, and then they don't really specify the vector per se, right? So the vector, oh, the vector itself, okay, is here. The vector itself is here. And in a reset vector, you set the on mouse. So and when something changes in there, you want to do something. So on touch, the mouse button was pressed. All right, that's very cool. So utilities, small self-hosted development tools is a formatter, linter, I suppose. No, it's a peephole optimizer that reveals optimization of code sequences and stuff like that. All right, so that's pretty cool. We have mouse. I suppose I'm not really that interested in mouse, to be fair. There's audio. There's audio device. Is there a list of devices in some way here? Okay, so there's not that interesting. So the system device. There is a console device. It's probably the most boring device. They should have had like a table of contents for different. Okay. All right. The screen vector is evaluated 16 times. Oh, that is very freaking progress. Okay. That is freaking progress. Right, so essentially, there you go. You can do graphics, and they even provide you an example. And you can write shit at 60 FPS. Okay. I have a question. What the fuck is this shit? Okay, I suppose this is this is some sort of a okay, I see. This is a label, right? The label is located in here, right? But so that means the names of the labels may include the triangular brackets, right? Because just like this triangular brackets kind of makes it weird, right? So it's just like, what the fuck is going on? Right, so in that case it makes sense, I suppose, right? So in that case it makes sense. There's also these things which I kind of vaguely remember, so there is an explanation of what they are. I need a map of these things yet again. So what are the commas? So it was somewhere at the yeah, here they are. So literal relative, right? And this is what we see in here. Frame. And I don't, okay, so literal relative. This one is weird. So there's something about the brackets that I do not fully understand, but maybe we'll figure it out. Maybe we'll figure it out. Anyway. Oh boy. So this is basically hello world. Maybe I'm going to just do something like that. What's funny is that we never really do anything with the vector, and the question is, what is the vector though? The vector for the console, right? So because whenever, so if you want to print to the console, you just print to the right. But what the fuck is a vector? All right, what the fuck is a vector? Vector is a value when a byte is received. Ah, it's for the input. I see. So if you wanna like receive something when the user like sends something to the standard input, you probably set up a vector or something. So yeah, let me go ahead and find ROM, and I want to remove this output ROM. I want to remove this output ROM, and I want to rename this thing to hello. Right. So, and I would like to maybe create like my stuff. Right. So this is going to be my stuff, and I want to move this thing there. Right. I want to move this thing there. So then, if I want to do an assembly, I want to assemble things, I'm going to be assembling my stuff, hello, and I'm going to be outputting that stuff, my stuff, hello, ROM. There we go. So, and the question is, does it put, okay, so it puts the symbols here as well, which is kind of cool. So what I'm thinking is that maybe I could create a make file. Is that a good idea, actually? Create a make file where I could say, if I want to create a hello ROM that depends on hello tal, what I have to do is just UCN assembly, right? Just take the tal and output ROM. So then I can just do make, and it just does that. So then I can have all hello ROM. So next thing we can do, we can create graphics tal. So this is a graphics tal, and I can use hello tal as sort of like an example where we can do things. So at absolute address, we start somewhere here. So interestingly, they don't show you this thing. They just say that at reset, you do that. But I mean, this is basically the reset vector. This is where the reset actually starts. So this is probably what they mean. Right, and this is where we sort of end and everything. And what we do, we just set the screen vector like this. We just set the screen vector like this, but this is not going to compile because we never actually specified any of these things. Right. So we never actually specified any of these things, and if we try to maybe build a graphics ROM, and then graphics ROM depends on tal, and this is basically like this. So I know that makefile has patterns, right? So I don't want to mess with them. I don't remember how to use them. So yeah, there's no on screen. So what we have to do, yeah, so this is what we have to do. We can even copy paste that. I really appreciate that they just provided all of these things that are copy pastable, right? So I can just copy paste this thing and start using it. Okay, so that's pretty cool. Right. So, well, I mean, I never defined on screen, so let's go ahead and just define it. So here is on screen. I don't think it's going to, we can say that it's also a vector, right? So that is actually technically true. And then we put brk in here. And this is where the most interesting thing starts, right? So we do the frame, but we don't really have the frame. So the question is, what the fuck is frame? Okay, so this is where frame is defined. Then I don't understand what the fuck all that means, right? So we'll have to ponder upon this stuff. But maybe this one is useful. So set them. So ports can be set to resize the screen for systems that support it. Oh, that's very interesting. So yeah, you can actually sort of do that. That is very cool. That is very cool. So what if I just don't do anything, right? So what if I just build it and try to UCN emulator graphics ROM? Right, it doesn't do anything, right? It doesn't really do anything. But the question is, what if we just print something on each individual frame? We already know how to print things in hello, right? So that means I can get the console. This is kind of cool, right? So you basically like importing devices, right? So, okay, I'm using this device and this device simultaneously. So, and to do that, I just sort of lay out the memory like that. I kind of like that. That's actually super cool. It's actually super cool. So, and we have a console, right? And then we're gonna have hello. And by the way, now, since we're a little bit more familiar with this entire thing, it would be nice to have print text. It would be unironically nice to have this function. So as you can see, we're slowly building up like a, you know, the library that we can reuse and everything, right? Because now, right, I want to be able to just say, okay, so essentially hello world, and then print text. Is that how we do that, right? Yeah, there we go. So it would be nice to have some sort of like a syntax highlighting and everything, but I mean, that's sufficient. So let's rebuild everything, right? So we don't have hello world, which is a bool at its word. Wait. Hello world. Is that a typo? This must be a typo. This just must be a typo. What the fuck? Anyway, so... And again, it doesn't even tell you where exactly that shit happens, okay. Anyways, so let's try to run this entire thing, and yeah, so it prints hello world 60 frames per second. It doesn't feel like 60 frames per second, honestly, but I assure you, it does that 60 frames per second. Not bad. Not bad at all. It would be nice to maybe put like a new line. So I suppose we can just put 10 in here, right? So this is 10, and if I recompile this entire thing, let's actually recompile and see how it goes. It doesn't look like a new line. Well, what's the new line? So it's, oh, it's a hexadecimal. God damn. Okay, so it is hexadecimal. Yeah, boy, now it feels like 60 frames per second. Brrr. Okay. It's pretty funny. But let's not do that. So I'm gonna just like put a comment in here. All right, we have in progress. So essentially, we learned two separate things, right? How to print on the console, and how to, you know, hook up your code into this like event loop of 60 frames per second, and we combine them together. Right, we combine them together, so now we understand shit. People saying that there is like a UX. Okay, so there is a mode for Emacs. Right, so let's actually quickly install that. Here it is. So let me just take that. Let me just take that. So I'm gonna go into Emacs mode and probably just install that. What's gonna be the best way for me to install that? So uxntol mode, and I'm gonna just do rc require and just install. It's my own like sort of system for installing packages and stuff. So it's a special macro that checks whether that specific package is installed, and if it's not installed, it installs it, right? If it's already installed, it just like requires it. And it's my custom system, and I developed it before things like use package existed. Just in case people ask, why don't you use this package? People, I've been using this shit for so long, use package didn't exist. Seriously. So... And this is the explanation why I don't use all of these, you know, systems like a Doom Emacs or Space Max. None of them fucking existed when I started to use this shit, right? So none of them fucking existed. All right, so can I just do uxn tab? That's much better. Would you look at that? To be fair, it's a little bit too colorful for my taste. What the fuck is this? Well, I mean, yeah, it basically highlights each individual like sort of special word and everything, so that kind of makes sense. There's something weird going on with... No, yeah, I thought there's something weird going on with the strings and everything, so a little orange, yeah. Feels a little bit orange, but maybe it's fine. Maybe we can work with that. Maybe we can work with that. Anyways, so anyways, how can we... So we can actually set this screen. We can actually set the screen. When this is the output, right? So this is the output. Deo is the output, but we have day2. So I have no idea what is a set theme. What is a set theme? Because it's definitely not a thing, right? So, yeah, the fuck is a set theme? Because I'm pretty sure it doesn't really exist. Wait. Oh. No, it doesn't probably exist. So I can actually comment out things. If I do make, right, if I do make, yeah, it doesn't. Like, why in here you're using things that don't exist? What's wrong with people? I didn't freaking know. So is that a label? It's probably not a label, but it's just like, that is confusing as hell. Anyways, so I want to put something on a screen. So I suppose to put something on a screen, we probably have to use the pixel thing. So paint a black pixel on background. Paint red pixel on foreground. So maybe we just have to go ahead and do that on each individual sort of frame, because that kind of makes sense. Fill a red rectangle bottom left on background. Alright, so let's just go ahead and make this entire thing unused label on screen. Oh, it even warns you about unused labels, but it doesn't tell you where exactly things are if there is an error. So there's hello on screen, and oh, this is actually quite important, right? So we probably want to set up this vector, right? So print, yeah, that's totally fine. Okay, so let's try to run this entire thing, and nothing is going on. I really don't see anything on the screen, so nothing is really happening, even though we set, you know, some things in here, so nothing really works in here. We can try to maybe, so this just sets, I suppose this just sets the, so port can be set to resize the screen, the system support, but reading from this port should always return the actual size. Okay, that's cool. As a program, use the screen size, position, response graphics. So here we probably just like a reading and maybe doing something. So SFT2, what is SFT2? Wait, there was a, you know, SFT2, there was a list of all of the words, like opcodes. So SFT, no, oh, here it is. So SFT is just like a, you know, shifts. It's probably a shift. Okay. Defines the pixel or fill mode layer to draw on optional. Okay, so this is just like a modes and everything. Okay, this is just the modes. I'm still confused about set theme because it's kind of weird. So it feels like maybe they want you to create like a label, like a set theme, but then it's so bizarre. Like, why did they do that? It's just so weird. Okay, so port defines 1B2 mode layer to draw on, optional and horizontal. Okay, so you have a this is very interesting. So yeah, set theme. Then you, so you can include sprites into the main thing. So, all right. Let me literally copy paste this. So this is on reset. So this is gonna be that. And then, so you just do the sprite. And then we can just use this thing. We can probably put it somewhere. Okay, so it does in fact highlight that. So it starts to feel like a, what's it called? Temple OS. Yeah. Temple OS. Because the author implements set theme most of the time, they just forgot. This is so bad. This is a really bad for documentation. Right, just assuming these kind of things. Right, Control F set theme. This is just like, I mean, oh my god, dude, like this is really freaking bad. Like, because this is a reference guide, and that means you're gonna be reading it out of order. You're gonna be reading it out of order, and you don't want to have things that are just don't make sense out of the context. This is such a cool idea. I'm a little bit disappointed with the documentation. Though, to be honest, we haven't encountered things that are like outright super confusing. It's just like, the things could have been better. Let's put it this way. The things could have been better because like it's not like unfixable problems. All of these things are very much fixable, and I even explained how. It's just like you didn't have to do it this way. Right. I'm still surprised there's the, yeah, that's already a pretty good achievement, honestly. That's already a pretty good achievement. I agree with that. So okay, so we're setting up some things. That is rough, man. Like that is straight up rough. Okay. Oof, 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 oof. So this is on screen and everything. So here we're just like setting the size, I suppose. X and Y. I don't really remember what are X and Y, but maybe it's a position and whatnot. And then we are doing the address, and then we're just drawing the sprite. And then we just set in the theme, and sprite is in. So that should just draw a sprite at a particular location, if I understand correctly, right? So let's actually try to build this entire thing, invalid hex, and it doesn't tell us where exactly it is. Bravo, 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 bravo. Okay, okay, okay. So so I suppose remove the heart. Are you telling me that? Oh, so it's stored in the beats. Oh my god. So it's not part of the... Why did you make it part of the language then? Why is it... Like, it makes it look like this is what you have to copy paste in the code. This is confusing. Like, don't... Invalid. Okay, so writing in 0 page. So this is an invalid token. So let me see. Why this is an invalid token? So set theme is, and what did I miss in here now? How is this an invalid token? Can I just like not do that? All right. So, oh, this is before. Okay. So it has to be somewhere here. No. So we also need to have like a system system R. So there is a system device in here. So let me find system. So there is a system device, and what does it do actually? Address an operation to allow basic memory management for ROMs and blah blah blah. Okay, so it's actually located at 0. It's actually located at 0, and nothing happened. Literally, because maybe like we need to set the theme first, right? So that's what we have to do. Not bad. Not bad at all. That was rough, man. That was rough. Like, the documentation doesn't have to be this way. It's just like, it's confusing on purpose, but maybe I am just dumb. Maybe I am just dumb, anyway. I have a feeling that it doesn't have to be like that. I have a feeling that it doesn't have to be like that. So especially with the heart, like, why didn't you explicitly say that this is not part of the language? Because it makes it feel like it is part of the language. Dude, at least put them in the comments. At least put them in the comments, because, like, man. Ooh, I see what they're trying to do in here, but this means, like, I don't know. Okay, so I said this thing is 9 out of 10. This is 8 out of 10. So I'm taking away 1 point from this thing. So this is 8 out of 10. So it doesn't really have to be this way. So yeah, I think I want to make, actually, yeah, let's make another break. So I need to process like all of that stuff. And after the break, I want to do something interesting. I want to try to make that heart move. Right, so one of the things we managed to achieve in here, right, which is kind of cool. We managed to copy paste things around and everything, and we managed to create a heart. Can we make it like move? Right, maybe we're gonna make it like bounce off of the edges or something like that, right? So this is gonna be the next step. So let's make a small break and then make it move. Yo, what's up? It's me, Azozin. We're gonna be steeping the tea. While we're steeping the tea, does anyone have any questions? So, Valeni, thank you so much for your subscription with the message T-sus. T-sus indeed. Sus. Sus. So, what do we have? UXN creator is in the chat? Oh my god, really? So, modify the docs. So set dim is clickable pointed. Oh, thank you. Thank you. So I really apologize if I'm being too harsh. Sometimes I'm just, you know, in the sort of in this mode where I sort of hyper focused, and because of that I'm hyper irritated and I sometimes cannot control that. So far this thing is actually great. I really enjoy it. It's really freaking great. It's really cool. So the complaints about documentations are kind of minor. I think I wouldn't even have them if I was not streaming. Right, so because like there's also extra layer of streaming because I need to sort of learn a particular thing very quickly, right? And if the documentation doesn't really allow me to do that, it kind of becomes difficult for me. So yeah, so it's pretty cool. So UXN is really cool, and I'm definitely going to be checking it again off screen for my personal recreational you know, needs, and just like see what I can do with it. But I definitely want to finish this exercise where I want to try to make the heart move. So I think it's going to be interesting. 3256, thank you so much for tier 2. Thank you. Animation is going to be fun. So I suppose the difficult part is going to be probably cleaning up the screen, because I can quite easily just allocate 2 variables, right, for X and Y, and just update them on each individual frame and make the sprite move. No big deal. But it's probably going to leave the trail, as it usually does. So the question is going to be, how can you clean up that trail? So I suppose one of the way you can probably clean up that trail is by inverting the theme, by swapping up the background and foreground bits and redrawing the same sprite again before drawing the next one. So you're going to be sort of switching back and forth the theme. So this is what I predict. I don't know exactly how it's going to go, but it's the most sort of like a logical thing. I think that's the most logical thing. No need to fiddle with the theme, but you got the right idea. Okay, I see. Because this is how it's usually done in old graphical systems, right? Because in old graphical systems, you can't really redraw the entire screen. So what people usually do, they sort of like patch the screen. So I imagine it's kind of the same. Zor, that's an interesting idea. Maybe Zor. But it requires figuring out how to, what kind of opcodes to call and everything. And I'm not familiar with all that. We'll see. Alright. We could. So I suppose this is sort of like the solution. I don't know what that is, but I don't want to spoil the solution for myself, so I'm not gonna click that link. I'm sorry. So the thing is, I really appreciate all the help, but for me, figuring things out is kind of part of the fun. Like figuring out things myself. So because of that, I'm not gonna look into the sent links or anything like that. I really want to figure out things myself, right? Otherwise, like, how do I even learn anything? So I'm not gonna look into anything. I'm sorry. So grabbing the tea. Looks like Roman embedded in the link. Yeah, that's what it looks like. All right, so let's try to basically make the sprite move. How do we put the sprite in a particular place? So this is where we assign X and Y, right? This is where we assign X and Y. So let me try to run this thing one more time. So this is where the heart is located. So, and it does make sense. So in terms of X, it's 20, in terms of Y, it's 40. So we can see that Y is bigger than X, right? So what if I change this thing to like 40, 40? So what is going to happen? Yeah, and it actually moved it like here. So this is basically where X and Y is located. So the next thing is, how can we sort of allocate 16-bit variable, right? If I want to allocate a 16-bit variable, if I create something like X, right? This is something like X. How can I say that this variable has to be, well, can I use a structure? Can I say something like position and then X, and this is like 1 byte, and Y another 1 byte? Like similarly to how we do that in here, but like in here. Can I do that? And then I can save the position in X and Y. I should be able to do that, right? Shouldn't I? I should be able to do that. So, and you know, we can load the position, but can I load it as 2 bytes? So there is an opcode load AK as, but is there load AK too? I wonder. So what kind of variants of load we have? So there is a LDA, just LDA. And what's the difference between LDAK? LDAK. Absolute address on the stack loads byte. So what's the difference between LDA and LDAK? I have a hypothesis that maybe one destructive and another one is non-destructive. Yeah, exactly. So LDAK is probably non-destructive, and LDA is destructive. But what if I want to load like two bytes, because X and Y is going to be like 2 bytes. Obviously, do I load them? I probably load them separately. LDA2? I couldn't find LDA2. So there is no LDA2. So this is supposed to be like a language. So yeah, okay. Sometimes it's kind of difficult to find like all the necessary things. It's like they're all like all over the place, and it's just like, where is all of that stuff? LDA2. Okay, and is it clickable? It's not even clickable. So LDA2. There's no even explanation. There's no documentation. Anyway, okay, so that's fine. So we have to do LDA2. And I suppose saving is sta. Yeah, so it's a store A, and there's a store 2, and there's store 2k. Okay, so the convention is clear. The convention is more or less clear. One of the things I want to do, actually, I want to take these coordinates, right? So first of all, let me try to run this thing, so that's fine. So what if I just take all of them? So this is the value. And I also need to take the address. But the question is, in terms of the STA, what comes first, address or the value? I suppose first comes the value and only then the address, I think. So that's going to be my hypothesis. Position X, and then we say STA2, right? So then we're going to have 40, which is Y. I'm probably doing something incorrectly, but that's fine. Right, I just want to test how this entire thing works. Right, so we're sort of like figuring out how to do these things. And LDA2. Right, first I'm saving some sort of a position in here, but then I am loading it again. Right, I'm setting the screen X and screen Y, then I'm doing the sprite. Like I'm basically setting the address, like I'm sending the address of the sprite into the screen address, and then I'm saying, okay, go do the sprite thing. Go do the sprite thing. Right. So the position has to be short, not byte. Ooh. Ooh. So if it's a... I see. I kind of vaguely... Okay. So if I take a look at that map... Oh boy. So literal absolute, literal zero page. Still don't understand it, but maybe it doesn't really matter, because like it's kind of similar to how you do that in here, right? So can't really know why it is like that, but okay. So let's just do that. Unknown absolute reference dot x. Position. So this is because this is one of the things I made. Okay, so that kind of worked, but then in terms of y it did in fact work. In terms of y it did in fact work, but in terms of x it didn't. So the question is why? The question is why. So what if I put y in both of these cases? Yeah, okay, so something with x, and I don't really know what exactly. So probably because the field of the thing. I really apologize. So the thing is, I'm really much irritated by backsetting. I just can't stand it. I'm really sorry. So I'm really sorry. Okay, so we've got that. And okay, that's cool. That is cool. So we allocated 2 bytes and everything. So now we should be able to do all of that sort of in a loop, right? So we should be able to do that sort of in a loop. Let me set the how is that called? The on screen, right? So let's actually set an on screen vector. Let's set on screen vector and so let me see. So I'm going to do it like this, right? So let's actually move this thing to on screen. All right. And now how do we set this stuff? Right, so we're setting the screen vector. So this is a set dim, and yeah. All right, so that should kind of work, right? So let me see. It seems to be working. That is very cool. So essentially, we initialize the position at the on reset, right? We initialize the position on reset, and now we can try to keep updating it. So first thing we can do, we can load it up. Then we can basically maybe add one to it, right? So there is, yeah, we can do inc2, right? We can inc2. So, but here's an interesting thing. We can do that non-destructively, right? So we can load it up, we can increment that, but we can't really store that easily back. We can't store that easily back because when you're storing thing, this has to be like the first address. This has to be the first address. I wonder if you can do like a swap to. Is there something like a swap to? Probably not. So in that case, maybe I'm gonna just do it like that. I know that it's probably not efficient. I know there's probably a better way to do that, some sort of special operand. I'm just learning. I'm just learning. Let me do a thing that at least works somehow. I know that if you are professional, you know really well this system. It is annoying to watch me doing it like that. I understand, but this is how I learn things. Yeah. It annoys some people, but that's how I learn things. I first just try to brute force and make the thing work. And then I see how it can be simplified, how it can be improved and everything. Right. So it's probably a very dumb way to do that. I know that, but that's how I do things. All right. So essentially we loaded this thing up. It's destructive, right? And then we save the incremented thing back. So to be fair, yeah, and then we like loading it again, which is again not particularly efficient, but that is fine, right? So that is fine. And nothing is really moving in here, right? So, but it is drawing in like in a certain position, right? It is drawing in a certain position. So let me maybe double check, right? Is it even calling the on screen right now? Maybe I forgot to, you know, to set things up because I did set up the vector. Like I'm pretty sure I did set up the vector. So. There is like a syscall. I think this is more like a syscall. Okay, so hello world. Right, is it? Yeah. So print text. Print text, and I'm gonna just try to do that. Invalid label. Just print text. Okay. So it only did it once. Which is interesting, right? Because it did work before. It did work before. So when I set, I remember like just doing it like this. Yeah, and it only, like it stopped repeating on screen, even though I set. Am I doing something differently this time? That's kind of interesting. Is there a font with all this opcode runes? Yeah. I don't know what you mean. So it doesn't repeat anymore. That's weird. That is absolutely weird. So on screen. Oh, you have to okay. You have to take an address. Okay. Yeah, that explains it. I see what's going on. Yeah, there we go. So I figured it out. You see, no need to backseat me. I can figure things out myself. I may struggle sometimes. I understand there is an urge to say, Zojin, you. I can figure out things myself. I'm not a dummy dum-dum. Well, I mean, I am dummy dum-dum, but I'm not that much of a dummy dum-dum. Right. I can read. I can understand things. Right. So, no need to babysit me, no need to backseat me, I can figure out things. All right, that's the point. Yes, that's what I'm talking about. The heart is moving. The heart is moving. Okay, so that's cool. Let me think. So there's probably some way to maybe, there's something maybe about the sprite thing. I have a strange feeling that there's something about the sprite thing. So let me see. So there is an address. There is an address. Let me. And sprite. We need to find the sprite. Defines 1-bit or 2-bit mode. Layer to draw on. Optional horizontal vertical flip on the sprite and the colors to use. The 8x8 sprite data to draw is specified by writing its location in memory. Okay. We already kind of know that. So we specified X and Y, we provided the address, and we set 1, and like we already know how to do that. So the color nibble defines which color is to draw for each pixel. The color nibble. The following table represents. If I understand correctly, these things are bits, right? So this is basically 8 bits. We can even confirm that, honestly. We can even confirm that. If I take the 0, 0, that's basically 0, 0, then 6, 6. Ooh. Yeah, there we go. So there's 2 bits in here, 2 bits in here, and as you can see, there's 2 bits in here, 2 bits in here. So that's what it is. And then FF is the full thing. So that means that sprite just defines this template, right? It just defines these templates on like where you have a, I guess, foreground and background, right? Where you have a foreground and background. So that means the colors are kind of defined by what? By... Is that how... Like, there's something about... There's something about the mode, I suppose, like a bit nibble control. So what is auto? So I probably need to read perfectly. The color is which color on each pixel represent all possible combinations, assuming a sprite has background of 0 and 3 concentric circles of 1 counting from sides. It's like it's a bit weird. It's a bit weird. So the author said that there is no need to mess with themes, and because of that, I'm looking for something that basically maybe flips the colors in here. And that's why I don't like being backseated, because I want to do things my way, right? So because it messes with my way of learning and understanding things. I'm gonna be messing with themes, okay? Right. Even the author of the systems can't tell me what to do. If I want to be messing with themes, I'm gonna be messing with themes, all right? So I'm gonna be messing with themes. So maybe what I wanna do, you know what? Can I create an anti-sprite? Can I create an anti-sprite? So I'm gonna go ahead and create an anti-sprite. So essentially, sprite, so anti-sprite. So we have an anti-sprite. So that means this one is going to be FF. So it's basically an inversion of those things, right? So it's an inversion of those things. Right. I wonder. So in Python, it's kind of probably easy to do inversion, but maybe it's going to be easier to do in C. Honestly, maybe it's going to be easier to do in C. Anti-sprite. Right. So. Anti-sprite. Yes. So I wonder if I can probably do something like this. A little bit of Emacs magic. Boom. And yeah, that's probably it. Can your Vim do that? I don't freaking think so. All right. So, can I just have something like size t? Well, I mean, it's going to be anti-sprite len size of anti-sprite divided by size of anti-sprite 0. So for size t less than anti-sprite length plus I, we're gonna be just doing printf u probably something like 0 to x. Right, let's put it this way. I'm gonna put a space in here. Well, I mean, this is actually not anti-sprite. This is literally sprite, right? So anti-sprite, sprite, boom, and we're computing an anti-sprite. So sprite I, so let's actually build this thing. So anti-sprite, C, boom. So length. I understand that. Don't quite get it right. So, and if I run the anti-sprite, yeah, that's cool. The thing I wanted to do is just this. God damn it, man! Like, why? All right, so, couldn't you just freaking? Well, I mean, technically, yeah, that's good. That's good. So we can work with that. I guess we can work with that. So this is the anti-sprite. So this is basically an inversion of these things. Honestly, I'm not sure. Maybe it would be faster to just invert bits manually. I don't know. Right. All right. So, and in here, what we're doing, we are just doing that. We're just doing that. Then we are setting an anti-sprite. So the anti-sprite, and we're just do it like that. So we're using the previous position. For the anti-sprite. Then we're updating the position. Then we are reading it again, right? So, and then we're setting it again. So now if I try to do that, that didn't fucking work. That's horrible. Like, why? Why didn't it work? Okay, so that's bizarre. So I wonder if I just so if I render. Wait, I'm an idiot. Why couldn't I do the dumbest shit ever, which is just 0, 0, 0, 0? This is because I'm probably a little bit tired already. So, so this is the end. Yeah. So why did I have to do that? That's so dumb. Bravo. There we go. That's the Tsodin way of doing things, right? That's the Tsodin way of doing things. I can get the shit done. I can achieve the goal without even understanding the system and how to use it properly. Right. So, yeah. So, like, why reading and understanding documentation if you can already solve the problem? You can already solve the problem. There we go. So I understand that there's probably a better way to do that, right? So I understand there's probably a better way to do that, but I'm already streaming for all like 2.5 hours, right? So, and I think I sort of explored this system like well enough for a short period of time that I had, right? Because I started from a complete scratch. I didn't know anything about this system, and I got the heart moving. I still do not fully understand the system, but I guess I can use it. So given enough time, maybe like a couple of days, I can write a simple game in it, right? So, and it's a pretty cool system, actually. This is a pretty cool system. Documentation is rough around the edges, but the author is open to that, open to fixing documentation, which is good. So I guess I'm gonna give it back a 9 out of 10. So my final verdict is 9 out of 10. Very cool thing, a very cool educational system as well. Right. So yeah, that was UXN. I suppose that was UXN. I'm gonna play with this virtual machine a little bit more, and maybe we'll do more things with it, right? So I suppose people have been using it as a compilation target. So there is a C compiler for this stuff, right? So maybe, yeah, maybe I'm gonna target Porth, but I mean it's also a stack-based language, so I don't know. We'll see. Sounds like a pretty interesting thing to explore further. Definitely. All right, that's it for today. Thanks everyone who's watching me right now. I really appreciate it. Have a good one, and I see you all on the next recreation programming session with Mr. Azuis. Love you all.